All right, so today I'm going to be looking at an optimization problem. This is an optimization problem where we're trying to minimize the length of a ladder. So what we have here is we have a wall. 4 feet away from that wall, we've got a 4-foot tall fence. Right, so this is the ground, and this is my vertical wall here. All right, and we've got a fence that is stretching from the wall over the fence down to the ground. I'm going to label that with a Z, and we're trying to minimize that Z in this problem. All right. Okay. So I'm going to call this X. I'm going to call height along the wall Y. And we're going to try and make an expression for Z using the values that we have here in the variables, and then try and minimize that function. So the relationship that I can use for this is that Z is equal to, or I could use Pythagorean theorem, Z is equal to x plus 4 squared plus y squared. So Z is the square root of x plus 4 squared plus y squared. Now, I don't want a function with 2 variables in it. I would like to try and get rid of either the x or the y here. I'm going to prefer to get rid of the y because, well, why not? So how can I create a relationship between x and y and try and get rid of that y from this equation? Well, I can say that x over 4 is equal to x plus 4 over y. That is just a similarity relationship between the 2 triangles right there. And if I solve this for y, I'm going to get y equals 4 times x plus 4 all over x. And I can plug that in here for z, or in for y, into this equation for z. X plus 4 squared plus parentheses around the whole 4 times x plus 4 over x being squared. Okay, so now in order to minimize, right, to find the minimum, I need to take the derivative of this and then look for any relative minimums and zeros and stuff like that. So this is it's going to be quite a derivative, right? So z prime, z prime is going to be equal to, I have that square root derivative on the outside, so it's going to be 1 over, stop that, I'm looking for the pen here, it's going to be equal to, it keeps making the thickness different, 1 over 2 times this really awful square root times, and by the chain rule now I have to take the derivative of what's inside. I'm not going to bother with that because when I'm minimizing z prime, I'm going to look for where this fraction equals 0. And frankly, I'm only going to have to look at the numerator and the stuff over here. So, I'll go through this and write out the whole derivative, but here's what we're going to have, right? We're going to have a product rule on this parentheses, so 2 times x plus 4 to the first, plus, now I've got to go ahead and do a, what have I got to do? Do a power rule and then do a quotient rule on the inside. Well, instead of doing that, I'm going to change that expression inside that square so that it's 16x plus 4 squared all over x squared. And I'm going to take the derivative of that expression. So that's going to be 32 with a quotient rule, right? Derivative of the top, the 2 is going to come out front. It's going to be 32. It's going to be x plus 4. It's going to be times x squared, the denominator, minus, it's going to be 16 times x plus 4 squared times 2x all over, and that's going to be the denominator squared, so x to the 4th. Okay? So z prime equals 1 over 2 square root x plus 4 squared plus 16 times x plus 4 squared over x squared times, by the chain rule, 2x plus 8 plus, this is going to be 32x squared times x plus 4 minus 32x times x plus 4 squared. This is going to be over x to the 4th. This is going to be over x to the 4th. And in fact, what I'm going to do is I'm going to go back here and I am going to put that back as 2 times x plus 4. Okay? So now the reason why I want that 2 times x plus 4 is because what I intend to do here is I can cancel out 2 of these. I'm just going to cancel out 1 and make this cubed. I'm going to cancel out this one here and make this cubed. And then what I'm going to do is multiply by x cubed over x cubed. Okay, it keeps changing the thickness of my line. I hate that. All right, and then what I'm going to do is I'm going to factor out the numerator. Okay, and see if I can figure out where z is equal to 0. Right? So let me go to the next page and take this down. Let me try and see if I can copy this stuff here and bring it to my next page. Let's copy. Let's bring it over here and let's see if we can paste this in so I can change this around. So z prime, let me get back the pen. Right? Oh, hey, look, it's still too thick. All right, so z prime is going to be equal to, now, my denominator, of course, is 2 square root of x plus 4 squared plus 16, what was that? 16 x plus 4 squared over x squared. But now my numerator here, right? I'm going to pull out, I can pull out 2 from each one of these, and I can pull out an x plus 4. And so I got x cubed plus, this is going to be 32x, and this one over here is going to be minus 32 times x plus 4. Okay. Now when I distribute this 32 in, I pulled out a 2, so both of these are 16. All right, so let me go back. Because I yanked a 2 out of each one of these, I got to change this to 16 and 16. So now I've got 2 x plus 4. I've got x cubed plus 16x minus 16x minus 64 all over 2 square root of x plus 4, and this should have been squared, plus 16x plus 4 squared all over x squared. All right? Wow. Derivatives a lot. It's getting down there, so let's see what we got. All right? X plus 4, x cubed minus 64 all over this ugly square root. I'm not going to bother writing it again because what I'm got up here is I've got two zeros, right? I've got a 0 at negative 4, and with this x cubed minus 64, I've got another 0 at positive 4. All right? I've got a 0 at x equals negative 4 and x equals positive 4. All right? And if I take a look at those zeros, you know, my length of my ladder, my length of x, going back to this previous page here, x can't be equal to negative 4, right? The only possible value here is x being equal to positive 4 out of these. And if I take a look at the denominator, right, you know, if I plug in negative 4, I've got 0 on top. I've got 0 here. That's definitely 0. If I plug in 0, I'm undefined.
Devani Renisinger, please come to the main office. Devani Renisinger, please come to the main office.
So, you know, really, it just looks like the only possibility here is that positive 4. 0 being undefined, we're not going to have a length of ladder being 0. You know, it's impossible for this distance to be 0 and right up against the fence and still go over and reach that wall. So obviously x has got to be equal to positive 4, which means within this problem that if I plug in to my original expression right here for z, that is if z is equal to the square root of x plus 4 squared plus 16x plus 4 over x squared, that's x plus 4 squared there. If I plug in x equals 4 into this expression, I will find the minimum value for what z is going to end up being equal to. So that should be the square root of 64 plus 16 times 64 over 16, so that 16s will cancel out. It looks like the square root of 2 times 64 should probably be the answer to this problem. And so this is the answer to your problem. And if you want to type it in using the formula, I know with some different numbers in there, trying to do this problem, trying to type in the square root and everything can get really bad. My number turned out to be nice and positive 4, though I've seen other numbers that were like cubed roots of 49 times 6, for example, or something like that. So you may want to use a calculator when you get to this point and trying to figure out z. Just please make sure you try not to do too much rounding. All right. Make sure you go out a number of decimal places when you're doing the division in the square root. Hopefully it all works out. Okay, if you have any trouble with this stuff, come see me during lunchtime on Monday or Tuesday, and I can try and help you go through this problem. Thanks for watching.